Okay, class, let me welcome you to our, our seminar for today. Today is the 11th day of June 2017. As I mentioned to you, I'm at UNESCO Paris for a 1 week meeting, and I am 1 hour ahead of you. By the program for today, Bileyi is going to have his presentation, followed by who do we have on the list? Who is next? Ademola Lawa is next, and then Jeremiah is next. All of that presentations will be tomorrow. So, if you are set, I am, and I want to call on Bileyi to make his presentation. Bileyi, you have the floor.
Thank you very much, sir. Good evening, class.
Yes.
I'm moving straight to slide 2. On slide 2,
What
I
are
have
you
the
presenting,
outline
gentlemen?
for. I'm
Gentlemen, what are you
presenting on
presenting? Yes.
I'm presenting on importance of AI, artificial intelligence, in educational system.
Okay.
So
Well,
I'm moving to the second slide,
yes.
which is the outline for the presentation. But I quickly want to digress on the outline.
Okay.
I have put down some questions that I want to throw to the class.
Wonderful.
Because while trying to do my research on the history of artificial intelligence, and immediately I try to pray.
Sorry, what did you call it now? Did you say artificial intelligence or artificial intelligence?
Intelligence.
Better. Go ahead.
Artificial intelligence, AI. So after my research, I just wanted to do some prayers regarding to the test class as my network, and I opened my Bible and I opened to Joshua 10:1, and I
Good.
find the word AI there. I was shocking, but I hope that the class can check the verse after the class.
Really? Okay. Good man.
So
Go on.
I'm moving to the third slide now,
You were
which I
there.
just want to quickly talk on the education and artificial intelligence definition. I know the class is above the educational definition, so I move up the artificial intelligence definition. On this slide, artificial intelligence is a branch of science.
Yeah, okay. I'm taking off Ugoke now because she's disturbing us. I'm removing her from the group. Now go on. I've removed her. Yes, go ahead. Yes.
On the slide talking about artificial intelligence definition, I want to buttress my point by saying since the invention of computers or machines, their capabilities to perform various tasks went on growing exponentially. Humans have developed the power of the computer system in terms of their diverse working demands or domains, their increasing speed, and the reduced size with respect to time. A branch of computer science named artificial intelligence pursues creating the computer or machine as intelligent as human. So I move over to the next slide, and that is slide 5. Main events in history. Are we there?
Yes. Well.
So the slide just gave us 1943 to 1950, but I quickly want to point out from 1922, whereby Karel Capek was the first person who first used the word robot in English. Then followed
First
by
use the word. First use the word what?
Robot.
No,
in
robot.
English.
Please pronounce
Robot.
it robot. Yes.
Robot.
Yeah.
Robot.
Good.
Yes. So in 1943, foundation of neural networks laid. 1945, Isaac Asimov, a Columbia University alumni, coined the word robotics. So I quickly moved to John McCarthy, who coined the term artificial intelligence. Demonstration of the first running AI program at the Carnegie Mellon University. So let's move over to the next, which is slide 6. Research associated with AI. If you look at some of the outline there, some of the researches that have been associated to the topic is knowledge, reasoning, problem solving, perception, learning, planning, ability to manipulate and move objects. I'm moving on to the next slide, which is the main of our presentation. How artificial intelligence enhances education.
Good.
So I'm going to pick these points one after the other.
Okay.
Is the class with me?
Yeah.
Slide 7.
Yes.
Hello, class. So the first.
Can we have a feedback from the class? No, hold on. Can we have a feedback from the class that you're on slide 7? Can you please confirm?
Hello, class.
Okay, now let me just check. Let me just check. What is the second point? Ademola Lawa, what's the second point on that slide? Busayo, what's the second point? The second bulleted point.
Personalized learning. Personalized learning.
Okay,
Personalized learning.
okay, that's fine. You got it. You got it. So please go on. Go on. Good. Yes. Go on, presenter.
Thank you very much. So intelligent ITS some far-off vision of the future. They already exist in a practical capacity. While far from the norms, they are capable of functioning without a teacher having to be present and can effectively challenge and support learners using different algorithms. The second point, which is personalized, much attention is usually given to what students learn. A historical tendency to focus on curriculum. However, a student learn is just as important. Advances in AI are giving teachers a better understanding of how their students learn and allowing them to customize the curriculum accordingly. The next point, which is adaptive group formation. Hello?
Yeah, go ahead.
Is the class with me? Okay.
So answer him. Are you with
By
him?
analyzing. Yes. Is the class with me?
We are with you.
Yes, go ahead.
Thank you very much. Adaptive group formation. By analyzing learning information, AI can generate groups particularly suited to certain tasks or groups that balance one's learner's weaknesses with another learning strength. The next point on that same slide is facilitation by example. Model of effective collaboration can be used to support learners and help them identify effective problem-solving strategy. The next point, which is intelligent moderation. Intelligent moderation allows human tutors, moderators, and teachers to analyze the data produced by large groups with the assistance of AI techniques like machine learning. In turn, educators can be more efficient in classroom. The next point, which is virtual reality learning. Taking a page from aviation education, VR-assisted learning allows for educational support in authentic environment and extend the boundaries of the classroom. Realistic immersion in virtual environment can provide learners with a richer understanding of the material. The next point, which is essay grading software. Software can instantly grade student essay. Is a significant benefit. Every graded essay add to the central database to which future essays are compared.
Willie, just a minute. Can I interrupt you for 1 minute?
Yes, sir.
Do you have? Can you turn on your video? Are you dressed to turn on your video?
Yes, I'm putting on.
Okay, fine. So turn on your video, and if you are going to present, please turn on your video so I can see. The others can stay with their images like you have them now. So please do that.
Okay, sir.
Okay, Willie, please continue. Please continue.
Okay, sir. Thank you very much, sir. I'm on the point. Real-time problem-solving assessment.
Good. You have just 2 more minutes.
Slide 7.
2 more minutes.
Explaining some of the points. How artificial intelligence. Okay. No problem, sir.
Okay.
Real-time problem-solving. This reduces the load on teacher by providing simultaneous instruction in a class setting. The next point, improving course quality. AI can analyze patterns in which a large number of students submit wrong answer to the same question by alerting the educator to this pattern. AI can help make teachers more effective. The last point, which is dynamic scheduling and predictive analysis. By using predictive computing, AI can learn students' habits and propose the most efficient study schedule for them. So moving over to the next slide, which is current trend. Machines that mimic human neural network already exist, and the term machine intuition is being used to refer to obtaining non-course knowledge. Which is this trend? Wise at present, AI is unable to transfer learning from one problem to another. The next step is likely to be transfer learning, where an artificial does not have to be trained from start every time, but can instead.
You have 1 minute.
Next slide.
1 minute.
Okay, sir. The next slide. What about the future? By 2025, AI and the robotic are expected to have spread into many aspects of everyday life. It has been speculated that by 2040, artificial intelligence may already be unstoppable, with human beginning to lose both understanding and control, and human mind gradually being taken out of decision making. And the last slide is my reference.
Wonderful. Thank you very much. Thank you very much. Thank you very much. I thought we will applaud him for a very good presentation. Very nice. Thank you. So let's take comments or questions. So if you have things to add to this good presentation. Lawa. Jeremiah. Johnson.
Okay, I want him to tell me.
No. I've gone past you. I've told you that when I call you, you must answer quickly. Johnson.
Nothing for now yet, sir.
No, I've told you I don't want to hear nothing for now. The next presentation, except you don't have the slides, that you must ask a question or make a comment. I don't want to hear nothing for now in my class. Is that clear? Okay.
Okay, sir.
All right, that's fine. So, Jeremiah, back to you if you can answer quickly.
Okay, sir. I want him to just try and analyze the steps that we can follow to create an artificial intelligence. Then the second question, I also want him to juxtapose the difference between artificial intelligence and expert system.
Yes. Adimola, are you awake now to ask a question? Okay, it's not. Billy, over to you.
Yes. Thank you very much, sir. Mr. Jeremiah. Looking at the steps of expert system and artificial intelligence, they are similar, but the difference is that the expert system is tailored to specific instruction or programming, while artificial intelligence is based on human intelligence. Have I answered your question?
Well, okay. Now, you've done very well, and I like your last but one slide, which is the one before the references, that artificial intelligence may overwhelm and overrun humankind. And that is what people are afraid of. That what will cause the destruction of humanity will be artificial intelligence when that is put at disposal of robots. They just form an army and they overrun the world. But that is not, that is just within the realm of stretching the imagination very far. But you see, with regard to education, you have made a very good attempt. If you look at the information processing mechanism of humans, let's take this class for instance. As I'm talking, is going in form of sensory data to your ears, auditory, your vision, and if we're doing some work in the laboratory, tactiles, another tactile, all the senses are at work more or less, and they will encode the data get it into what we call schema, plural is schemata, and it goes into a short-term memory system, goes to the medium term, and go to the long term, memory system. Now, the artificial intelligence will mean that non-human objects will now be able to undertake this kind of processing. Ordinarily, they on their own cannot, but it's some kind of programming that will enable them to do that. And on account of some form of mutation, they may end up being even more intelligent than the human species and all of this kind. So in education, it's important. It will help people who have challenges with data, with processing information, maybe on account of some disability. So that is going to be some useful area of it for the future. Once again, thank you, and you've done very well. Let's move on to the next. Thank you, Billy. As always, we're very proud of you. You are very proactive. You are very you a good leader for the class. Olarewaju Aribi is here. He's just auditing the class. He hasn't got, and the mind says EdTech. He hasn't got a computer that the microphone is working properly. Olarewaju, if you can hear me, try for the next class to get your microphone working properly. So let's go on to take on Ademola Lawal. Lawal, are you ready? No, not yet. Ademola, are you ready?
I'm ready, sir.
Yeah, but why did you talk when I asked you to now? When he finishes presenting, all of you will have to ask him a question or make some comment on his presentation. So, Ademola Lawal, what are you presenting on?
So I intend to present two topics today, which
Okay.
is the features of the Core i7 and
Yes.
interrupts too.
Okay, that's fine. Yeah, okay. Ademola Lawal, you have the floor.
Okay. Good evening, class. On to slide 2, where the introduction is. i5, i3, and i7 are actually naming same.
Yeah, first of all, tell us the title of your presentation, and then you can.
Okay, sir. Okay. The title of this presentation is Features of the Core i7 processor. So I move on to the next slide, introduction, where I said that naming them Core i5 and i7 and i3 is just actually a way to show a difference in the processors. So the Core i3 is just like the entry level, while the i5 is the mainstream, and the i7 is for the high-end. So anybody using the Core i5 is just anybody that requires, probably people that use systems for gaming that needs a bit of memory, they choose the Core i5. So if you need if you want to use the processor for something that has higher processor usage, they have to go for the i7. So I'm going to the next slide where I have the features of the Intel Core i7 processors. I said the first one is the new platform architecture. The new platform architecture. So the new Intel microarchitecture for a single processor system includes three discrete components of the CPU, which is the graph, the memory controller, and which is also known as the NOT bridge, and the I/O controller, which is also known as the South bridge. So Intel just found a way to combine the North bridge and the South bridge together, so that it's going to reduce some sort of bus usage in the what's called the processor, so that the system can actually access information at the reduced phase. So Intel moved the memory controller and the PCI express controller from the NOT bridge to the CPU. That it reduced number of external data ports that data has to traverse. These changes help increase data throughput and reduce latency for memory and PCI express data transaction. Moving on to the next slide, we have the higher performance multiprocessor systems with QPI. Intel integrated the memory controller on the same die. They did it in such a way that the memory controller is on the same die as the processor, which will make it kind of have high speed.
What's the title? What's the title of that slide that you are taking?
Higher performance multiprocessor systems with QPI.
Okay, so now you didn't tell us to move. I mean, you didn't tell us. You just jumped to this one, but go on anyway. But from now on, let us know which slide you are moving on to.
Okay, no problem, sir. I'm moving on to the slide 5, where I have the higher performance multiprocessor system with QPI. So I said Intel integrated memory controller on the same die as for i7 processor and introduced the high speed QPI data bus. So each CPU has access to local memory, but you also can access memory that's local to other CPUs via KPI transaction. I'm moving on to the next slide, where I have CPU, the CPU performance boost via the Intel Turbo Boost technology. That was introduced by Intel on the core i5 and i7. They have to go together. So this feature automatically allows the active processor core to run faster than the base operating system when certain conditions are met. Now, if the CPU has to go through two operations, and in the core i7 where we have like four power. So it's activated when the OS requests the highest processor performance state. It's Intel terminology for overclocking CPU, allowing them to run faster clock speed. I told you, I already said before that both core i5 and core i7 support the trouble, so it's not a new thing. It's both of i5 and i7. I'm moving on to the next slide, where I have improved cache latency with the smart L3 cache. The improved cache latency with the cache is a block of high-speed memory for temporary data storage located on the same silicon that has CPU. So if a single processing core in a multi-core CPU requires specific data while executing instructions, it must search for the data on the local cache, the L1 and the L2. So if the data is not available, also known as cache miss, it then accesses the larger L3 cache. So this is just a way of making a sort of improvement in the processing speed of the core i7. This was an improvement. This was a kind of improvement that Intel added. So it shares across all cores, and its inclusive nature helps increase performance and reduces latency by reducing cache snooping traffic to processor cores. I'm moving on to the next slide. Optimize multi-threading performance through hyper-threading. Hyper-threading just simply means that the processor can actually carry on two tasks at the same time. So Intel hyper-threading increases CPU performance for multi-threaded tasks and is helpful for multitasking when several applications are running simultaneously. All core i7 processors and mobile i5 processors support hyper-threading. So it's also known. It's both in the i7 and also in the i5. Just sort of. So the next slide, I have the higher data output via the PCI Express 2.0 and DDR3 memory interface. So the PCI Express 2.0 is just an improvement on the previous PCI Express 1.0. I said this feature, the processor feature the PCI Express 2.0, which doubles data throughput for PCI Express 1.0, just times 2, while maintaining full hardware and software compatibility with PCI Express 1.0. So I'm moving on to the next slide. We have improved virtualization performance. Intel added some new features as hardware assisted program table management and directed I/O in the core i7 processor as chipset that allows software to improve their performance in virtualized environments. So virtualization is a technology that enables running both OS side by side on the same processing hardware. So I'm moving on to the next slide, where I have the remote management on network system with Intel Active Management Technology. This improvement is actually a plus for engineers to actually access their systems remotely. So AMT provides system administrators the ability to remotely monitor, maintain, and update systems. Intel AMT is part of the Intel Management Engine, which is built into the chipset of a NARM system. So this feature allows administrators to boot systems from a remote area, track hardware and also software assets, and perform remote troubleshooting and recovery. Engineers can use this feature to manage deployed automated tests or control systems. So I'm moving on to the next slide, where I'm talking about.
We have 2 more minutes. 2 more minutes. 2 more minutes.
So the first one is that i7 processor has a larger cache, and the larger the cache, the faster the processor can work. So this advantage is an advantage for i5. So it actually increases the processing power, the processing speed, and it has 4 physical processing cores instead of 2 previous ones, and with i5 4 virtual cores. So it's like having 8 cores in just one system. It has 4 physical cores. So it has a better performance due to increased number of cores. So because of this number of cores, the performance increases. So on the disadvantage of the core i7, I might say, now talking about the two, I can't actually say that there's a certain disadvantage, but that's if there's a disadvantage, it's going to be on the laptop and not a disadvantage on the Intel Core i7 itself. So there is no distinct disadvantage right now. So the conclusion is that the Core i7 family of processors, based on the Intel NALM micro architecture, offers
many new and improved features that benefit wide range of application, including test, measurement, and control. Engineers and scientists expect to see pressing performance gain as well as increases in memory and data throughput when computing this microarchitecture to previous based on the line microarchitecture. So the processor is ideal for computer 3D games, multitasking, and multi-threading applications. The main thing to remember is the i7 CPUs are at the high end of the product line. So i5 CPUs are in the middle and the i3 are the entry level. The Intel Arc is one way to, and it allows you to select multiple CPUs to compare side by side. So it's your choice. It depends on what you want to actually use your processor for. That's how you are going to be able to choose the perfect processor to choose. Thank you, sir.
Thank you very much. Can we applaud Ademola Lawa? Yes. Over the last 4 years, I've not touched a machine that is not a Core i7. I did that because after the series of generations of processors that are used, I found that speed is as like 8 cores working. As you mentioned, I found it to be quite fast. I found it to be, it has a lot of power, and efficiency in it. The system I'm using now has a Core i7. Going across the table, what kind of processor does your machine use? Billy, Famuide, what about you?
i5, sir.
Famuide, is
i5,
Famu?
sir.
Okay, what about Jeremiah?
i3, sir.
Okay, what about
i3.
Busayomi?
Core i3, sir.
Okay, Demola Lawam, that's making all the noise. What kind of machine are you using? Processor. The man is not answering again. Have you answered me, Billy?
i3, sir.
I3, okay, that's fine. So you could try the Core i7. Maybe when we meet in class, I'll let you see even the boot up process, or when you ask it to do some tasks, like if you are doing, like we learned in class on Saturday, doing maneuver, if you set the two running at the same time, you need to see how speedily the output. When you ask it to do like maneuver, it will say processing. I think you were in class Billy on Saturday, and also from Johnson. He will say processing. This other one will not even get it that. You just get the result so rather quickly. Why I settled for the Core i7 in all my machines is that I had to do quite a lot of programming, and I need something that will not weary me in terms of waiting for a task to be achieved. So questions for just one person now to ask a question from Deborah Lawa. Anybody?
I have a question, sir.
Go ahead, Busayo.
Okay, I just want to ask, does the Intel Core i7, is it the same thing for laptop and desktop? Because I know
Of course,
Core
of
i3,
course,
they
of
are
course.
not the, they are not the
Of
same.
course, of course.
Okay.
It's the same architecture, completely the same architecture. Yeah, any
Is it,
other?
is it, is it,
It's the same architecture, the same architecture.
okay.
Yes,
Okay.
I did say that only one question, but let me just, as I mentioned, I want everybody to ask a question. Jeremiah, what's a question or comment or contribution? Johnson.
Thank you, sir.
Johnson, yes.
I'm with you, sir.
Go ahead, yes.
Yeah. While he was talking, I quite appreciate him trying to manage the time, and some of those things that you also noticed about his presentation was the fact that what Billy did, that he will tell us I'm on slide 13, slide 14, and not just saying I'm moving on to the next slide.
You are correct.
And
So
which
please note that. That's fine. That's fine. That's fine. So please note that for next time. Yeah. Billy, comment or question for him?
Nice presentation, Miss from Adina Lawal. I just want to ask if we have expansion slot for graphic card on Core i7 architecture.
Yes, Lawa.
Yes, sir. We do have an expansion slot for graphic card.
Okay, that's fine. That's just a straightforward answer. So let's go on to your next presentation, Ademola Lawa. That will be one of the backlogs. And you tell us the title, and then you make your presentation. Yeah, so press on Ademola Lawal for your next presentation.
Okay, thank you, sir. I'm going to be presenting on interrupts, and I'll be moving to the third slide where I have interrupts, the definition of interrupts and what interrupts is about. So,
Good.
interrupt is a request of the processor to suspend its current program and transfer control to a new program called interrupt service routine (ISR). Many routines are always running in the background independently of our instructions, so such as checking the keyboard to determine whether a character has been typed in. So when an interrupt occurs, the hardware executes the instruction at the specified address instead of following the normal protocol, the normal flow. So an interrupt is a request of the processor just to suspend what it's doing as at that time. So why do we need interrupts? The structure of the processor of any computer is conceived so it can carry out instruction endlessly. So as soon as an instruction has been executed, the next one is loaded and executed. So if it appears that the computer is inactive, when it is waiting in the processor for the windows for the next action, it does not mean that it's actually stopped working. It has only just started again when instructed to. It will just start again when it is instructed to start the next operation. So now we have types of interrupts. So interrupts can actually be categorized.
Yeah, you see, Ademola Lawal, you have missed the point again. We have said it over 1 million times. When you are going to slide number 3, you tell us slide 3. You go tell us slide 4. So please do that.
Okay, sir. All right, sir. So I'm moving on to slide 4, where I have the types of interrupts. Interrupts can be distinguished into 3 types. So it's either software interrupts, hardware interrupts, or exceptions. I'm moving on to the next slide. That's on slide 5. Software interrupts are initiated with the INT instruction, and as the name implies, are triggered via software. So when an interrupt is issued, the processor automatically transfers the current flag, the code segment, and instruction pointer into the stack. So software interrupts are always synchronized with program execution. This means that every time the program gets to a point where there's an int instruction, an interrupt is issued. So when an interrupt is issued, the processor automatically transfers the current flag and the code segment to the next pointer. So the interrupt number is internally multiplied by 4 and then provides the offset of the segment, which is the interrupt vector here. So that way, the interrupt vector gives the entry point of the interrupt handler and return to the original program that was launched originally. So software interrupts are always synchronized with program execution. This means that every time the program gets to a point where there is an int instruction, the interrupt is issued. So I'll be moving on to slide 6. Slide 6, which is the second one, the hardware interrupts. As the name also suggests, the hardware interrupts are set by hardware components or by peripheral devices such as the hard disk. There are 2 types of hardware interrupts. So we have the non-maskable interrupt, which we call NIM, and the interrupt request. That one is maskable, so we call that one IRQ. So we have the non-maskable and the interrupt request. So I'm moving on to slide 7, where I have the where I explain both the NIM and the NMI and the IRQ. And NMI in the PC is generally not good news, as it's often the result of a serious, and when there's an hardware problem, that's when the NIM is issued. Such as memory parity or an erroneous bus application. So an NMI cannot be suppressed. So that's why we call it non-maskable. So it indicates a serious failure, and the computer with incorrectly functioning hardware must be prevented from destroying data. So it must be prevented rather. So the next one, we have interrupt request. On the other hand, interrupt request can be masked, unlike the first one, which is unmasked. The interrupt request, the IRQ, can be masked, and is the opposite of the first one. So it activates. The interrupt requests are generally issued by the peripheral device. When the peripheral device wants to prompt the processor, that's when the interrupt request is issued. So I'm going on to the next slide, which is slide 8, where I talk about the third type of interrupt, which is exception. The particular type of interrupt originates in the processor itself. The production of an exception corresponds to that of the software interrupt. This means that an interrupt whose number is set by the processor itself is issued. It is the processor that issues such interrupt. So when this exception occur, generally is when the processor can't handle alone an internal error caused by the system software. So we have 3 types or 3 main classes of exception, which is fault, trap, and abort. I'm moving on to the next slide, which is slide 9, which is the where I explained the class of the interrupt. So the fault issues an exception prior to completing the instruction. So the same EIP value then points to the same instruction that created that exception. Thus, it is possible to reload the EIP and the processor will be able to execute that instruction, hopefully without an exception. So when the processor is actually running such program and it encounters a problem, it's a fault exception. So it will try to reload it again. Hopefully, it is not going to encounter such problem again. So the next one is the trap. The trap issues an exception after completing the instruction execution. They say the points to the instruction immediately following the one that gave rise to that exception. So this instruction is therefore not re-executed again. So the trap is actually when it has actually finished on the previous instruction. So I'm moving on to the next slide, which is slide 10. And it's a continuation of the previous slide where I'm talking about the third class, which is abort. This one is not good at all. So the abort usually translates very serious failures, such as hardware failures or invalid system tables. Because of this, it may happen that the address of the error cannot be found. Therefore, recovering program execution after an abort is not always possible. That abort is actually just terminate the instruction when the error is encountered. It terminates it entirely. And unlike fault, you do not re-execute it. So now, I now deem the fit in the next slide, which is slide 11. Let's talk about signals. Because I found out that signals and interrupts are actually
you have 2 more minutes. 2 more minutes.
There's a distinct difference in signals and interrupts. So I tried to explain it. I said a signal is a notification to a process that an event has occurred. Unlike interrupts, that is trying to tell the processor that there's another job for you to do. So a signal is just a notification to a process that an event has occurred. So signals are sometimes called software interrupts, and this causes few problems. Signals are different from software interrupts, or only a different. Okay, I'm saying that is there a difference in interrupts and signals. So before answering this question, you should know that the concept of an interrupt has expanded in scope of for interrupt, that is making people to now mistake it for signal. So the 80 times exist family has only added to the confusion surrounding interrupts by introducing the int instruction. I'm moving on to the next slide, which is slide 12. I'll continue to talk about the signals. In order to avoid further confusion, I will attempt to use the most common meaning for these terms. Also, in order to differentiate between signals and software interrupts, consider that one.
Yeah, okay. Please try to round up now. Yeah, you said most of these ones before.
I'm moving on to slide 13, where I continue. A signal is said to be generated for a process when the event associated with the signal first occurs. Signals can be sent to one process to another or to itself or by the OS to a process. So
okay, now Adimolawa, that's fine. I think you just summarize quickly. You're talking about events on one of the slides that can raise a signal. We can get the examples and all of that. So just make your last 2 sentences and then let's end this. Go ahead.
Okay.
The last 2 sentences. 2 sentences.
Okay. Signals are a prompt to tell the CPU that there's a problem, there's something there's an event occurring.
That's sentence 1. You have it last sentence. Okay. Go ahead. You have one last sentence.
The last one, the last slide.
Last sentence, not slide. Sentence.
Okay. Events such as the keyboard interrupt generate signals which are sent to the target process. So
okay, that's fine. Thank you. All right, that's fine. You've used up your time. Yeah, let's just appreciate him. We all have the slides, and we're building up on what Gbileyi had already presented and all of that. So he has come with a different dimension, maybe strengthening areas where Gbileyi made mention of, and areas where Gbileyi had some strength. You have some weakness in yours, but together we have a very good discussion on interrupts. We're expecting that the others will share their own papers or presentations with us in the coming days. As you note, we can only take 1 hour for each of these. We have spent 1 hour already. And Jeremiah, we have to take your presentations tomorrow. I also need to go rest. As I said, I just came into Paris this evening and straight into this class. But it's quite worth the while. I need to
Thanks, sir.
wish you a very nice evening. It's 10:05 at my end here. I'm sure it's like 9. I'm 1 hour ahead of you.
9:05.
9:05. But that's fine.
9:05, yes, sir.
Yeah. So we're seeing. You see, tomorrow I have a meeting with a team in Lagos, also online. So we're not going to do 8 to 9 tomorrow. We're going to do. Actually, I can run that one till 8:30. So you stand by at 8:30 for the class. We'll run the class tomorrow, 8:30 to 9:30. So Jeremiah, we're going to take you first. So you're going to be standing by. Okay. Bonne nuit. That's what they say in French. That's good night. And God
Good
bless you.
night, sir.
God bless. Take care. Bye bye.
Au revoir, sir.
Au revoir. Au revoir. Au revoir.
Good
Thank
night,
you.
sir.